let me do this. All right, number 4. Because we're going to need a calculator in here, so I'm kind of working through things here, and I'm videotaping it so you have it. Number 4 says, all right, f of x is equal to the square root of x. And the point we're using, 2 square root of 2. So this right here tells me that's a c. This is f of c. So we have 2 parts of our tangent line. And if you want to think of it like this, the tangent line is equal to the linear approximation. So if we get to the tangent line, we're in business. Now to get to the tangent line, we need to figure out the slope at the point too. So I need f prime of x to start with. And just really quickly, I'll turn this into x to the 1/2 power. So this is 1/2 times x to the what? Negative 1/2 power? Sure. So this becomes 1 over 2 times the square root of x. So that's f prime of x. So what's this going to be? I plug in x is 2. So f of 2 is equal to 1 over 2 times the square root of 2. Now, if you could leave it like that, that's perfectly fine, because we're going to end up doing some calculator stuff with it. Or if you wanted to, you can multiply that by the square root of 2, that by the square root of 2, get the square root of 2 over 4. If you rationalize the denominator. It doesn't matter. Alright, but first off, are we okay with this? Now, the tangent, which they call t of x, which is our linear approximation, is going to be the slope, which is this, times x minus c, which is 2, plus f of c, which is the square root of 2. And honestly, I wouldn't change a thing from that. I wouldn't distribute it. I wouldn't do anything, because there's not a whole lot you can do after you try to distribute it. But first and foremost, having that's kind of cool. I can actually use that. And then we figured out one of these two. It leads to these 3 things. So far, so good? Yes. I'm going to show you. Alright. Now we need to get into a calculator so we can start using the table. So I'm going to open this guy. And I'm going to create a new document, because there's a whole bunch of garbage that's going on here. Don't want to save anything. I want lists and spreadsheets. So here, I'm just going to call this, since I'm creative, input. And I'm going to call this f of x. Oh, can't do it. I'll call that f, and I'll call that t. Or can't do that either. Alright, so at least I named all three columns. It's a good habit to get into naming all the columns so you know exactly what they're going to be. Now the input was 1.9, 1.99, 2, 2.01, 2.1. Yes? Okay. Now the function, if we go into the center one, we just type in what the function actually is. Function's equal to square root of x, right? So I'll go square root of, I don't want to put in x because x doesn't make any sense. I want to put in the name of this variable. Well, what did we name the column here? Input. So you go to variable, and variable lists all the different names that we have. Input is what we want, so I have the square root. This becomes the square root of the input, right? And you can see that right down here. You hit enter, and then you get all your answers. Now this becomes a little bit trickier. When we want to start and we want to put in the linear approximation, which is the tangent, we have to go back and say, all right, well, the first thing is going to be a fraction. 1 divided by 2 times the square root of 2. And right out of there, that doesn't work. Go over there, hit that. Then that's going to be times. Now it's the input because it's the x value. So I need the input, which is going to be right there. The input minus, what's my x value? It's 2, isn't it? That was the x value that we started with. And that's going to be plus the square root of 2. Because that was f of 2. And then you hit enter, and now we have, cancel. We have the function, which is the exact answer. Well, exact-ish. And we have this value. So we can take a look at how they're changing. This is the fourth, tenths, hundredths, thousandths. This is the change in the 10,000ths place. This is changing, what, 1, 2, 3, 4, 5, 6 places past the decimal. So this is a pretty good approximation of what's going on. This one is right on the bat. This guy is pretty good because it's 1, 2, 3, 4, 5. The 6th place is changing. And this one, the 4th place is changing. So they're all pretty good representations of what's going on. So in here we just put the function, which is the square root of x, but we didn't call that x because we're not allowed to call that x in the calculator. So we just give it a fancy name, input. And that's how we set this up. Does that make sense? That pretty much is linear approximation. You take something a square root, and there's no way that I'm going to figure out the square root of this, but I can figure out that, even though there's a lot of other stuff going on. Sometimes the original is a little bit easier to deal with than the other one. Yes? So that's going to be, this part right here is f prime of c, or f prime evaluated at 2. This is basically x minus 2, and this is the original function evaluated at 2. Yeah, so that's f prime of 2, that's 2, and that's f of 2. Good on that one?